All right. Hi, everyone. This is the Friday, January 27th JupyterHub team tutorial. We're going to keep this fairly informal. The intent of this tutorial is to basically give the JupyterHub team a chance to share with all of us the work that they've been doing, and to help our day-to-day development team just get up to speed on all the current activities of the JupyterHub team. So we posted an agenda that I can try to drop that somewhere so people can follow it. Yeah, so we'll just get going. The first person to speak is Min. Take it away.
All right. Thanks. I'm gonna start with just an overview of the rough structure of JupyterHub, and then some of the things, some details of the new things in the most recent release last month. So I'm going to talk about where the project is right now, and we had our OHAT 7 release last month in December, and then we've had a few point releases fixing things with the new stuff since then. So we're at 0.7.2 or 0.7.3 right now. So the rough structure of JupyterHub looks a bit like this, where we have kind of a proxy in front, and then we have this big hub application that has a few components. It has an authenticator and a spawner and a database storing the state, and then it starts notebook servers for each user, and then updates the proxy to route requests for given URLs to the user server, and then handles everything under the hub URL. And then the notebook, when the notebook receives a request, it asks the hub, who is the user who just asked for something from me. So there's four basic pieces of JupyterHub instance. There's the proxy in the front, which is generally, but not necessarily, the configurable HTTP proxy project that's on the JupyterHub org. It's a Node.js proxy that can be updated while it's running. There's also an Nginx implementation that UV's done. There's the authenticator, which handles authentication, and a spawner, which handles launching single user notebook servers. And then there's the hub, is the process that manages all these things. And the authenticator and the spawner are these APIs that can be swapped out, different implementations that handle authentication in different ways, or handle allocating servers, notebook servers in different ways. So an authenticator is a simple authenticator, given anything that can take a username and password and return whether they're the right pair, whether that's LDAP or any service can implement an authenticator that just needs to define one method that says given a username and password, check if they match, and then return the username on successful authentication. What's turned out to be more common is using OAuth to integrate existing services, which makes a bit of sense. So we have a package, OAuthenticator, that defines the basics of integrating an authenticator with an OAuth service, and you can extend that to hook into your own OAuth provider if there isn't one written for that already. And the authenticators that have been written so far, see, there's some of the common ones. So Authenticator, people have contributed implementations for a variety of services. There's a remote user one for putting JupyterHub behind a Shibboleth Apache instance, Shibboleth authenticated Apache instance. There's an LDAP authenticator, and then UV wrote a temporary authenticator for as a step toward replacing TempNB with a JupyterHub instance. And in general, configuring authenticators is a matter of saying, which user should I allow? If your authentication system can authenticate more users, then you actually want to have access to the hub, and then which user should be able to administer the hub itself. Start and stop other users, add users, that kind of thing. Spawners generally are an API around. It's a little bit more than an API around just starting a process. that has a web server. So there's a start method that needs to return, just start a process somewhere that needs to return the IP and port where that server started. It needs to be able to check if that process is still running and then stop it. And all the things, basically all the methods in the JupyterHub application is tornado coroutine. So everything can be async and slow, and the app should remain fairly responsive. And the one additional piece is that since the hub needs to be able to resume while the spawner may or may not be running, there's this additional notion of state, which is a place where the spawner can put information that should persist over time. This is often, when using Docker, for instance, this could be the container ID, so that you can resume a container rather than creating a new one on every start. And some example spawners that we have, there's the Docker spawner, Kubi spawner, batch spawner for batch systems, systemd spawner, and then a wrap spawner that is kind of a multiplexing spawner that lets users choose which of a number of spawner configurations they want to use. So with our latest release, the main new thing is called services. So we're kind of adding another entity to our collection of pieces in the hub architecture, and that's a service at the basic level is anything that can talk to the hub's API that's not a user. So one version of a service is called a managed service, and this is a process that the hub starts when the hub launches, and it starts this process with a bunch of environment variables telling it what the service's name is, where the hub is running, the hub's API. It gives it an API key so that it can make requests to the hub's REST API, and it monitors it and keeps it running. And then there are external services, which can be anything that wants to talk to the hub that's not started by the hub. So this could mean if you're deploying JupyterHub itself with a supervisor or systemd or something like that, it may make more sense to start your services with the same process manager rather than telling hub to do it. And this lets you run services kind of distributed across machines with Kubernetes or however is appropriate for you. It can also mean that the service isn't a process at all. It's just a way of giving an API token a name and access to running the notebook server. So you can just say, I want to assign an API token to an activity that's like adding users with this script, and you can call that a service. So what can services do? So services, one of the main things services can do is run a web service. And so if you say when I start this service, it will start a server at this IP. JupyterHub will automatically add that to the proxy at this services/services name URL, and that lets you run things like NBviewer or web applications that are served that sit next to the hub behind the proxy. And then 0.7 also adds this hub auth class that you can import in your service that implements the authentication mechanism that single user servers use. So when a request gets a cookie or in master an API token, it can check who that authentication item corresponds to, and then use that to determine if a given user should or if a given request should be allowed. And then a service can do anything. One of the absolute most basic thing a service gets is an API token to talk to the hub. So if nothing else, you can just say a service is anything that can talk to the hub with via the API. So what are the goals of what services are for? The basic case is just anything that interacts with the hub, any kind of process, periodic activity where you want to interact, tell the hub to do something, shut down servers, start new servers, add new users, delete users, any kind of monitoring. It can also be the Nbgrader form grader, which is a web service that uses hub authentication, should be able to use the pieces to relieve some of the headaches of deploying the form grader. So it shouldn't need to talk to the proxy anymore. It can just say, hey, I'm a web server. these are the users that should have access to me, and then it should be able to do that in a simpler way and just run it. And the hub will start it, and the hub will help it identify which users should be allowed to use it. And there's the calling idle servers script that we have. Potentially, it could be used for sharing files across users. That's something that we'll get to later. There's a shared notebook server that we were working on just last week. So you can start a notebook server, a regular single user notebook server, as a service, and this can allow users to share the same notebook server, not with in the absence of real-time collaboration. It has limitations for doing that, but it at least lets you put a server that multiple humans can have access to. And then Peter also implemented support for Nbviewer running as a service. And implementing support really means being able to run with a URL prefix, since it will start at this /services/name instead of root, and enabling authentication if the service needs it. And that's kind of the background that I wanted to summarize for the current state of things. Anybody have questions about that before we move on to other things?
Thanks, Min. I do want to point out, please feel free to ask questions right now. We also have a GitHub repo for this tutorial. If you guys hadn't seen it in the chat window, there's a link there. And if you're not looking at the link, the org is Jupyter-resources, and then the repo is tutorial-devteam-JupyterHub-2017. So in the issues log, you can ask questions there if you're too shy to speak up, or you have something that you would love for us to read instead. You can use that as a resource. Any questions for Min? Hi, Carol. Okay, great. So the agenda is also in that repo, and it looks like the next 30 minutes we'll be looking at, we'll be hearing from Jess, Brian, and Yuvi about teaching with JupyterHub. So first on the list, we have Jess, who's going to share a little bit about using services and enhancements with Nbgrader.
Thanks. So Min mentioned the form grader a little bit already in his talk, so I'm sort of just going to go into that in a little bit more detail. Let me share my screen. While that's loading, for those of you who might not be as familiar with Nbgrader is a system for creating assignments in notebooks, and then when it's used in combination with JupyterHub, it can also be used for releasing those notebooks to students, having the students submit them, collecting them, and then doing the auto grading all through JupyterHub. So what I have here is a server that I just spun up this morning, and I have a JupyterHub config here, which is pretty simple. It has a lot of comments in it because I just pulled this from the Nbgrader docs, but it's much simpler to set up Nbgrader with JupyterHub now that the services API exists. So basically what we have is this part, which you can see most of the screen, where we define the service that has a name. You can give it whatever name you want. Tell it to run Nbgrader form grade, and then you tell it what URL to start up Nbgrader form grade as. This is for a managed service, but you can also do it with external services, which I think maybe Brian will talk a bit about. The only additional piece of configuration that we need to do is actually in the Nbgrader config itself, so I can show you what that looks like too. If you notice, though, in the JupyterHub config, there was a key for the current working directory, and that's where it'll start Nbgrader up. So this is the Nbgrader config that exists in that directory. And what you see here is that we set the IP and port to be the same as those that JupyterHub expects. And then we set the authenticator class to be this hub auth, which is uses the hub auth that Min talks about, and it has a few additional things that it does that are Nbgrader specific. So the configuration is pretty simple. That's really all that's required. And we can just run JupyterHub now. You'll see it says adding service from Greater Course 101 to proxy. So we can now access that at services from Greater Course 101. So if I come to my browser, and this is the IP address that JupyterHub is running at. So go services from Greater Course 101. We'll see it's running. There's nothing there because we haven't actually done anything yet, but it's there running. JupyterHub started it for us. So I'm just going to quickly go through just, we have our instructor account here, and there's our course files here. So I can run Nbgrader assign to create the student version of the assignment. Oh, uh-oh. I think there's maybe an issue with this database. This is what I get for doing a live demo. I know what it is. It's that when JupyterHub started, it created the database file for Nbgrader to use, but I think it set it to have the wrong permissions. So I just need to set that. Let's try this again. Yeah, there we go. And then we'll release that. We can now log out of JupyterHub and log in as a student. The students have this assignments tab where they'll see all of the assignments that have been released and are available to them. I actually have downloaded problem set 1 from an earlier run through of this demo, but normally it would appear here as like an assignment to fetch. I'll go ahead and submit this and log out and log back in as the instructor. And back to my terminal. I can now collect the assignments, auto grade them, take a moment. And now if we come back here to the form grader, you see the assignments there in the list, and we can go through and start grading it. So with the services API, this is like a much easier process than it was before. And we're continuing to make some improvements to the way that the form grader integrates with JupyterHub so that it'll continue to be an even easier thing in the future. We're planning on actually having it be an extension to the notebook rather than a separate process itself. Thanks.
Thanks, Jess. It was great to see those that workflow. Cool stuff. All right, we are moving on to deploying with Ansible and using JupyterLab. Brian, you're up.
Hello, everyone. So let me share my screen here. Share screen. All right, can you see the screen here?
Yes.
Yeah.
Okay, great. So yeah, I teach computational courses, data science and computational physics at Cal Poly. And as part of that, we've been deploying JupyterHub in our courses for a couple years now, and to help us with those deployments, we have created a set of Ansible roles and top-level deployment files to help with the deployment of JupyterHub. And we've encoded that in this repository here. It's on the JupyterHub GitHub org, and it's the JupyterHub-deploy-teaching repository. And I want to sort of walk through sort of what's involved with this type of deployment. And so I first want to emphasize this statement right here, and that is this particular deployment is targeted for small to medium groups of trusted users working on a single server. So here we're teaching up to maybe 100 students in a given quarter, and we can manage that on a single large server. And those students are more or less trusted, so we'd be willing to give them a shell account on a Unix server. And in terms of sort of the constraints that we've chosen, so this again is a single server. We're using Nginx as a front-end proxy for serving the static assets, and then also as a termination point for SSL. And the entire configuration of the server is done using Ansible and scripts. And you can either set up SSL using your own certificates if you have that, or we also have the option to use Let's Encrypt, which does make it quite a bit easier. And it's important to note that this particular configuration does not use Docker or containers in any way. I think in my experience so far, if you're able to run on a single server and you need to use a tool like Nbgrader along with it, Docker complicates things more than it simplifies at this point. We're trying, as Jess mentioned, we're working on simplifying aspects of Nbgrader, and so I think that will be easier to deploy with Docker eventually. The prerequisites are that you have an empty, fresh Ubuntu server running a latest stable release or a fairly recent Ubuntu version works fine. You've already set up your local drives that are going to be mounted. You've got a directory for or a drive that's mounted for home directories. And the big thing is a valid DNS name. To really set this up, you need that. Optionally, an SSL certificate. Again, you can use Let's Encrypt if you don't want to purchase your own certificate. And then Ansible 2.1 or greater. And so I want to switch over here and show you the file that we have that encodes the top level variables for this setup. And here's the required settings. So you would specify the path to the home directory for all users, the JupyterHub admin users. So this directly maps onto the underlying JupyterHub config. This is an initial whitelist of JupyterHub users. And then we have two optional kernels, the R kernel and the bash kernel. By default, this configuration will install the Python or IPython kernel, and then you can optionally install the R or the bash kernel on top of that. And then you need to create this proxy auth token that's part of the underlying security configuration of JupyterHub. And then there's this one option by default, JupyterHub will kill the single user notebook server and the proxy and the hub. Basically, it will kill everything when you restart it. You can set cleanup on shutdown to be false, and it will actually leave single user notebook servers, the proxy, and a lot of it running, and that's really nice. If you need to make changes and reconfigure the server, but you don't want to interrupt the people working. We have a list of default packages that will be installed. So we're using Miniconda to manage the Python packages. So you can here's our default list, but you can add more to that. You can also add pip packages, and then for R, you can have a list of CRAN packages that you can customize. So in terms of optional configuration, the default would be to use just Unix passwords. You can optionally use OAuth, which we typically do on a real courses. So you set OAuth equal to true, and then the OAuth client ID and client secret would be something that you get from your OAuth provider. So for example, from GitHub or Google. Here is the Nbgrader configuration. We've updated the Nbgrader configuration here to reflect the upcoming release of Nbgrader that's based on services, and it also supports multiple courses and multiple instructors. The call idle servers service, we're now running this as a managed service, and this will basically look at single user notebooks server activity, and it will stop those single user notebook servers if a user has not been using it for some specified amount of time. There's some other optional settings here that I'm not going to go into. I actually want to, in the last little bit here, show you what our live server looks like for the running quarter. So this is the admin page for one of the admin users on JupyterHub. And you can see for this course, we're using GitHub OAuth. And you can see here all of the students who are running. And then I forget exactly what I have the call idle set to, but it's around 24 hours. And so all the other users' notebooks have been stopped. I can add users here if I need to. And then also can show you the form grade interface that we have set up. And so this is for an actual real live course where this is at the end of the third week. And so students have done about 6 assignments. And one thing that's relevant here is that all of this, the grading interface is anonymized. And so when I click on an actual assignment here, you're not going to see the students in the course, which would be a privacy violation. But it's also anonymized for our graders, which is really nice. And so they can just go through these different notebooks and do the grading. Another thing that's important to note is even though this configuration that we've optimized it for also running Nbgrader, the default configuration file here actually doesn't install Nbgrader. So Nbgrader is false. And so these Ansible scripts would be very well suited to any small team of people wanting to work on a single server. And here's small, a single server like this, we easily support up to 100 users. Where you wouldn't want to use these Ansible scripts would be sort of internet scale numbers of users, or if you don't trust these users and don't sort of know them individually. In that case, you would want to probably be using multiple servers and something like Docker or another container solution to manage the users. And I think that's all. I guess I'll say one more thing, and that is we're trying to create branches in this repository that and the branches are following the versions of JupyterHub that they support. So the 0.6 branch is a deployment based on Jupyter 0.6. Master here is currently supporting 0.7, and so we're trying to follow latest Nbgrader and JupyterHub on this repository. And I think that's it.
All right, great. Thanks, Brian. Are there any questions from our studio audience?
This is Carol. I'm going to just make a quick comment. The Ansible scripts, once I had the domain name set up, it and the server itself took only a matter of minutes to deploy it using Let's Encrypt, and it was really nice. So I think something that Brian suggested, which I think I would like to do, is make a cookie cutter to make it even simpler, and also get some additional documentation on how to get a domain name and server, but that's a little more down the road.
Yeah.
But it looks great, Brian.
Thank you. Yeah. The thing that takes the longest, once you have a server up with a domain name, the thing that takes the longest in the deployment is just installing all the packages. If you're, for example, to command out most of the Python packages and R packages, the deployment takes, I don't know, probably 10 minutes or less than 10 minutes. It's very, very fast. So.
Super. Thank you so much. Let's see. Anyone else? No. All right. So the next talk on the agenda is from UV. And UV's going to talk a little bit about the Berkeley Data 8 architecture overview. So Data 8 is the initiative. UV, you can explain it in a little more detail. But it's an initiative here at Berkeley to work with undergraduates to provide them with core competency in data science. So it's a really cool course that they can take.
Hello, can people hear me?
Yeah.
Can you see my screen?
We can see 2 screens.
Ooh, interesting. I'm not sure how to make that be 1 screen. This is really weird. Can you read the screen with the slides, or?
We see you are sharing your screen. Now we see Carol.
Okay. I'm using desktop Linux, and of course, I think I don't need to say anything else. Sorry guys, give me a second. I'm going to just turn off my 1 screen so that I can have only 1 screen.
Okay, sounds good. This is Matthias's opportunity to tell jokes. Do you have any in your back pocket?
No. I think you're all allowed. I think we were all allowed 1 slap per day if he says really bad jokes. Okay.
From up here, we're broadcasting from the Berkeley labs, and we can see the Farallons from here, right beyond the Golden Gate Bridge. It's a really beautiful day. There we go.
Okay. Yes, that's better.
Okay.
Hello. So I'm UV. I work for the Wikimedia Foundation now, but I've been helping out with UC Berkeley on their JupyterHub deployments for a while now. So this is for their Spring 2017 Data 8 class. A little bit about Data 8 is that it's a really large course. I think like this time there's about 650 students enrolled in it. And it teaches basics of programming, but with a tint towards data literacy. That's like their core thing that they care about, is to allow like people from all backgrounds. So they have like lots of people from, like things that are not traditionally considered computer science, such as urban planning or like literature, taking this class. And there is also connectors. So they have, for example, a neuroscience connector that uses the techniques they learn in data science in the Data 8 class and how they can apply it to neuroscience. Or, like same thing for literature. I think they were like analyzing Shakespeare or something along those lines. I don't entirely remember, but there's definitely people doing things like that on this. So there's like a lot of people using this, and there's a lot of people teaching it. So it's like a fairly large affair that uses a lot of resources and time. And it's been going on. This is like the third time this class is run. I think the beginning they were basing it off of Jess's wonderful deployment that was based off of Ansible and Docker. And this is the first semester where they've switched to using Kubernetes for everything. I'm going to be fairly quick here because like if I try to start explaining how Kubernetes works, that's definitely far more than 10 minutes. So this is going to be more of an overview with like hanging points so people can ask questions for later rather than like an entire demo. So and before I start, I also want to make sure that it's not just all me. There is like a fair amount of other people involved in it. Ryan Lovett from Berkeley was like very involved. There was also like a group of students under the Berkeley Blueprint team who were involved. So not just me. Okay. So these were our requirements for when we started designing this, which is we wanted to like 1,000 students running concurrently was our target. We know we wouldn't hit that. Like average, it's going to be maybe 200 to 300 students, but we wanted to be able to design for up to 1,000 students who are using this. And we want it to be completely reliable. We don't want to have any failures of spawning. We don't want to have downtime, even when we have to upgrade. And we want to make sure that when we do deploys, we know that it's like, this is just going to work. Like there is no uncertainty here. This is a solid piece of infrastructure that you can take for granted. And so you can focus on, you know, like all the other things that your course needs to focus on. And like, this is just like solid underlying infrastructure. We also wanted to support multiple hubs. There are many courses that are using JupyterHub here, and they have different requirements. The neuroscience course, for example, requires that we mount extra data in all of the users' containers with like, you know, different set of packages. And there is even a statistics course that's actually using R Studio that we have spawned with the JupyterHub with a fun series of hacks that we should probably talk about sometime soon. And all of these are like, you know, there's one hub per thing, and we want to be able to manage all these without tearing our hair out. This is also not tied to any single cloud provider. We wanted to be able to like use Google or Microsoft or AWS, depending on whoever is giving us free money at that time. And we also wanted to be completely reusable by other people. We did not want anything Berkeley specific in there. And this also will help us keep our code clean. This current setup also grew out of Wikimedia's JupyterHub setup that I was working on. So that also helped make it like be a bit agnostic to the particular specifics of the case. We also wanted it to require very minimal upkeep and ongoing maintenance. We did not want to spend more than, I don't know, an hour or two every week from the sysadmins to actually keep this up. And we wanted to make it as self-serving as possible to the instructors themselves. And these were the design principles / goals that we, like, these are the principles that we set out in the beginning to guide the decisions we made as we designed this. We wanted to be 100% reproducible. Every deployment, like if I, like I can with the Git hash represent exactly what is running in data 8 right now. And this is very useful because this means I can tear it down and bring it back up, whenever I want. In fact, like it takes about 20 minutes now to bring up a new hub where we are like very confident that it'll just work. And we delete and recreate the hub like almost every day until like the start of class, so that like I think like 4 hours before the start of class we just like recreate it from scratch, so we know exactly that it'll work. We also wanted to scale up and down trivially. We wanted, like, when we wanted to add extra capacity for like 300 users, it was just like one single command. And we also tested this very well, so we know that just works. But we also wanted to scale down so that, I think if you have like more than 30 students, like this is actually pretty good. Like I think below that count, Brian's deployment is probably better. But we wanted to be able to like not like require, this is only useful if you have 500 students. This is useful even if you have like 30, 35 students. Again, like 100% reusable, no Berkeley specific code. And we also wanted to be self-healing. We wanted to reduce hacks as much as possible. So if we had to do something manually to fix something, we'd only do that once. The second time that happened, we would make sure to like spend the time to properly fix it so we don't have to hack it again. And we've been fairly good about enforcing that. Right, so we picked Kubernetes. Why Kubernetes? It provides higher order primitives, which I think is like the fundamental reason we picked it. The analogy I like to make is like Kubernetes is to Docker as Ansible or Puppet is to Bash. So you can do all the things you can do with Kubernetes with just Docker, but you have to build a lot of scaffolding around it. The same way you can do all the things that you can do with Ansible or Puppet with just Bash, but you have to build a lot of scaffolding around it. And like if you're just doing something simple, Bash is probably fine. But if you like want to do something in a bit more large scale with a bit more process around it, then Ansible or Puppet or something like that is going to be much more useful. And I think the same is true of Docker and Kubernetes right now. It also runs on all cloud providers, on-premise installations, and that is wide adoption in industry. So we can basically like ride out on a lot of things for free. When we started doing it, we were like, oh, we want this feature, we want that feature. And like we always found that there was like some random company that was like building it and releasing it as open source because they wanted it for like their own cluster, and then they were able to contribute back upstream. And that's been really nice. There is the Borg paper that Google released about Kubernetes, which explains like a lot of their reasons for making the things they've made, and also like it's really nice read even if you don't have a background in systems engineering. So I highly recommend people to read it if they haven't. This is the architecture diagram that I put up yesterday. It's a little crowded, but the three red boxes are nodes. So this is like the conceptual overview of one Kubernetes cluster that has 3 nodes running with about 16 gigs of RAM each. So like I don't even have to know that there are 3 nodes running. All I as an operator care about is that there is 48 gigs of RAM. So if I give each student 2 gigs of RAM, I can run up to 24 to 22 students here. And you will also note that the hub and the proxies also run in the same cluster. So this is one of the advantages of using Kubernetes versus Docker and Ansible separately, which is that like everything is in the cluster. So like it's not like the hub process separate and we need to make it connect to Docker somehow, and like the hub and proxy need their own high availability story. It's all in the same cluster, so we have only one thing to manage, and that's this Kubernetes cluster. And you'll also see that there is mixed colors in there. So each of these boxes is either a user's container or a hub container or a proxy container. And they're all mixed, right? Like we have one cluster on which we are running, like in this case, like 2 courses. But at Berkeley, I think we right now are running like 4 different hubs on the same cluster. And this number just basically scales up. It's like very trivial to add a new hub. So we'll probably like end up running like almost all our courses on like one cluster. You will also note that each of the users have a volume attached to them. So each user gets their own disk of 10 gigs each. So what happens is when a user logs in, we ask Kubernetes to create a persistent disk for us. So in case of AWS, this will be EBS, or in case of Google Cloud, it will be Google Cloud Storage or whatever your cloud provider has. So we create a new disk specifically for that user, and then we attach it to their container. This has a lot of advantages, such as like if you have a centralized storage pod and if you have a lot of users, it's very easy for one user to basically like eat all the IO and then make it really hard for like the other users to access their services. And it's also very easy like to make that be a single point of failure where things just start failing if that single thing fails. So yeah, we have this instead. And scaling this up is really easy. If you want to add more users, we just add more nodes and end of story. You can ask more questions about this later. And each hub is completely represented by a single config file. This is basically what the config file looks like. We have support for different hub providers. This is just like for Google, but we have support for GitHub and stuff as well. And you just specify a name, and then you specify what single user image you want to use, and what capacity of disk you want to provision for each of these users, how much memory and CPU you want to specify, and the cull timeout for like killing inactive users. And we also specify like metrics, like you can just set up the stats. So we do collect metrics about like how many pods succeed, how long they take to spawn, etc. And you can just set up all of that in the YAML file. And once you do set that up, it's super trivial to install. We use this thing called Helm, which is part of Kubernetes, to install this. So with that first line, it'll like basically spawn, it'll like apply all of the config, like it'll create a new hub with the config that I've specified in my YAML file. And it's also easy to upgrade, right? You just do the same thing. So I will edit my config.yaml, push it into Git, and then I will run the upgrade command, and it'll do the minimal set of changes required to apply that. And it'll also happen in like a very nice fashion that doesn't destroy data or like cause downtime in any form of it. So this is our deployment workflow. We have a production cluster and a staging cluster. All hubs are deployed from the same configuration, both the production and staging cluster. So when we make a change, we deploy it to staging, and then we verify it works, and then we can deploy to production, and we are like fairly sure that it'll just work. We haven't had any outages that we haven't caught in staging at all. And all configuration is kept in a version Git repo, so we can go back and see like if we deploy something to staging and it like it doesn't work, we can always just either go back or make changes and go forward. And it's fairly easy to experiment with it. We also have no user disruption during deploys. The proxy runs a separate pod that is not touched during deploys. So single user notebooks are like there is no disruption. There's no even disconnect of the notebook kernel. So we can just do this at any point of time, and it's just fine. We have a system called Nbgrader that we use to distribute notebooks to students. Time check. Do I have time for a demo, for a minute? Hello.
Sure.
Okay.
Yes, you do.
Okay. So quick demo. So this is the website for Data 8. It's actually open to everyone. It has better styling, but my computer is broken because Linux. So if you look here, it just has I don't know if you can see this. It has a list of courses, a list of lectures, the lecture videos, the reading, and also has assignments. So if I click this, I'm just going to click homework 01. It actually will link me to our hub in which I have logged in. So it's now doing a get pull. And all of the things in that homework are now in here and displayed to me. And I can just click the notebook and then it'll just show me what is in there and I can start working on it. This takes a while to load because, again, my computer's broken. Right. So that's it. And this works fairly reliably. And people use a GitHub account. There is also a GitHub repository for keeping all assignments and other homework related things as well. So it's very easy for them to to keep track of what's going on where. This is also fairly generic. We want to rename it from Nbgrader because there's Interact project into something a little bit more descriptive, and then write more documentation about this at some point. This also is great because this means that you don't need one big file system. You don't need NFS or something for all the users to be on the same file system. Each of them can get their separate disks and can still use this, and it's still fine. Let me go back to this. Okay, so that's the quick Nbgrader demo. Assignment collection, auto grading, and instructor services. So there is a lot of work that's actually being done on this, but I don't know anything about it. What happened is EECS already had a lot of auto grading stuff that they had built over the last few years, but they did not use notebooks for any of that. But over the last few months, the same people who had built it, it's called OKPy. You can go to okpy.org to check it out. It's actually open to everyone. It's not Berkeley specific. So they have added notebook support for it over the last few months. So there is not much documentation about it, and I actually haven't seen it in action. But from talking to the people I know who used it, it's actually apparently really good. It does a fairly nice auto grading. It doesn't require shared notebook space, and it also has fairly detailed ways of providing feedback to students, as in when they're doing their work, rather than having to wait for it towards the end. If there is interest, I'll try to ask the people who are building and maintaining OKPy to do a demo to see how that goes. Okay, right. So that's about the end. The next step is we want to do a better autoscaler. Right now we have a super simple autoscaler that when the cluster starts to become about 90% full, we just add more nodes automatically. So we know we will never end up with it being too full, but we want to make it more intelligent by integrating it with the color. So we can optimize resource usage and only create new nodes when required, but also opportunistically cull things so that they can stay up for as long as we want them to, but we do delete them when we can reclaim a node and save some money. We also want to deploy it to at least one another institution to make sure that we didn't bake in any Berkeley specific things in there. I'm hopefully going to do this for Wikimedia sometime soon. We also want to do more hardcore security and performance testing. We did do performance tests before we started this. We had 125 simultaneous users logging in and starting the hub at the same time, and we looked at the stats and this is great, it totally worked fine. And we couldn't do more simply because the infrastructure I had built to simulate these users was breaking down before the hub itself was having any problems. So we need to do better there and build better infrastructure to actually do the testing to see where this goes. So that's it. Questions? Lots of activity in the chat.
Way to go, Yuvi.
Yeah, thanks, Yuvi. That was great. Any questions from the audience?
Hey, Yuvi?
Yeah.
Pete, I might have missed it, but for the student assignments, when they're working on it and they're saving their work, is that persisted back to a Docker volume or something?
So yeah, that is persisted back to the So there's a persistent volume, that's the Kubernetes concept. So yeah, that is kept in a Kubernetes volume. That is, we have one separate volume per student that is attached to their container.
Cool. Okay, thank you.
Do you know how many hubs are the deployment is currently running?
I think it's currently running 4 hubs, and I think next week requires maybe 3 more to show up. Am I here? Did people hear that?
No, we got it. We got it.
Okay.
Anything else?
Thanks.
Questions? All right, great. Thank you so much, everyone. So for those of you who are joining a little bit late, we just went through, let me just tell you first that we have a repo with our agenda in GitHub, and Carol actually created a bit.ly link for that, a short link, and that link's obviously HTTP, and then it's bit.ly/jhubtech, so just the letter J, HUB, and then TECH. So we've got the agenda in there. You can see that now we're moving on into the future of releases for JupyterHub, and Min is going to share some of that with us. And I think you're still, there we go. Just repeat for the folks who are joining, we also, in that repo, we have in the issues, you can ask your questions there if you feel uncomfortable speaking up over the video. And we are recording. Thanks.
All right, you see my big gray square?
Yes.
Okay, good. So talking about a bit about where things are headed in the next release. Mostly the next release, maybe next release or 2. A couple smallish things in the JupyterHub architecture. One is abstracting the proxy API. So right now we mostly rely on a particular proxy implementation called configurable HTTP proxy, which has the main feature of being able to be updated without dropping connections and properly supporting WebSockets. Nowadays, the only feature that configurable HTTP proxy has that other proxies don't is tracking activity, which we use for things like shutting down idle notebook servers. But a recent PR to the notebook repo means that the notebooks track their own activity, so we can define a simpler spec for what a proxy in front of the hub needs, and then we can have a Python API so that proxy implementations can be another one of the things that is swapped out, just like the authenticator and spawner. So we can use the Kubernetes access points or Nginx proxies or Apache or anything that you can, the requirements are it better support WebSockets, and it better, it needs to be able to update its routing table without dropping connections, and that's it. And we started to work on that. Another feature is allowing multiple servers per user. So in contexts where the hub is exposing a variety of computational resources, so when, in particular, this comes up when the hub is on like a primary access point for a cluster, such as at UCSD, or at the Minnesota Supercomputing Center, where they have a variety of profiles that you want to start a GPU job or a job with this much resources, or this many resources, this much memory, this many nodes. It's useful. It may be useful to have, I want to start that job, leave it running, and then I want to start another job with a different collection of resources. And JupyterHub right now requires you to shut down the first one before you can ask for a different one. Christian Barra is helping us out with implementing multiple servers, kind of relaxing the assumption that each user has exactly one server, which is a small change, but it's one that has implications all over JupyterHub's code base. So it's a bit of a tricky one. So it'll take a while to get finished. And then an important thing is for the courses and things where the single server per user is really important, and getting JupyterHub out of the way as quickly as possible. We want to make sure that we still serve that well, rather than making it increasingly complicated for the class-style deployments to use. As people with the services and talking about shared notebook servers with different groups of users, I think it would probably make sense to move JupyterHub to the way JupyterHub handles its authentication to basically implementing OAuth itself. There are Python libraries for implementing this, so I've gotten started in essentially running JupyterHub itself as an OAuth provider, and then using OAuth to handle the authentication between services, single user servers, shared servers, all that stuff. Should make it easier to have kind of a wider variety of access patterns and services that are using the hub for authentication. And the main reason for this is in order to protect users from each other, we have this notion of where we have to isolate cookies by these path prefixes, so that a user can't compromise their own server and then get other users to visit their server and then steal their cookies and then spoof them and in general do compromise the whole system by compromising their own server. Using OAuth will make it easier for that to not. It'll allow us to have a simpler system that doesn't have that problem to fight with. And the big short-term work is the hub share service. So one of the reasons we built the services system was to make deploying things like Nbgrader simpler. And we've done the first part of that in terms of making it easier to deploy additional web services like the form grader. The piece that's still sticky that Brian alluded to, especially if you're using Docker or distributed files, is the assignment distribution system that currently relies on the file system, because you need to be able to have, you need to distribute the assignments to the users and then get the assignments back, and students need to turn in things and that stuff. And so hub share is a really, really simple. The goal is a really simple sharing system for taking a directory of files and then making it available to some group of other hub users or groups, and then being able to download those shares into other single user servers. And we're exploring kind of a basic spec for how to do that. We're still figuring out whether it makes sense to do the entire thing as a simple REST API or use WebDAV for the storage API. Still not 100% clear which way would be preferable, but neither one should be super complicated. And the target use cases is especially the Nbgrader needs of being able to push and pull files to students, but also just generally being able to, in a shared computing context, being able to say, all right, I made a thing, I want other people to be able to grab it and take it to their own servers. And specifically, this is not meant to address things like the real-time collaboration stuff, right? That's real-time collaboration is about starting a running notebook server with access to some particular context that you can both log into. And most of the pieces needed for that are already done. It's just the single user server stuff that needs to happen. It's this sharing model that for when the users are staying semi-isolated from each other, that there's this gap for in implementation that we're looking to address. And I believe, yeah, that is the gist of our immediate horizon for JupyterHub stuff. So multiple servers per user, hub share, and adding the proxy to the list of things that you can swap out implementations of. And I think that's all we have.
Well, that's great. Thank you, Min. Questions from the team, from folks who've joined us from the community? No.
Or if you just want to talk about what you're doing with JupyterHub and questions or things that you wish were on the immediate horizon that aren't. Nope.
Bring it. Nothing. Folks in the room.
Hi.
Hi.
I have a question. Can you guys hear me?
Yep.
Okay, so you mentioned integration with external proxy servers, right? Is that something that's already in 0.8 release or it's being worked towards? For example, if I want to split out the reverse proxy that's configurable node proxy, but replace it with something else that's more native to the Kubernetes environment, is that something that's going to be?
That's the idea. It's not implemented. The first piece of it is so UV's done most of the spec for with the spawners define the API for so you need to write a little Python class that represents implements adding routes, removing routes, and getting the list of current routes is basically all the proxy needs to do. And so that's the first piece that UV's mostly done is defining that API. And then once that's done, then we'll ship, just like we do with spawners, we'll ship just the default implementation of that. That will be the configurable SU proxy. And then we'll allow additional packages, just like we did with the spawners, to implement the Kubernetes version of that, the Nginx version of that kind of thing. But yeah, that's just getting started right now.
Yeah. I also want to add that. Oh.
Go ahead.
Oh, I just want to add
the main.
Go on, man.
The main thing in JupyterHub, in addition to that, is retrieving the activity timestamps from the single user servers instead of from the proxy, but that's very small.
Yeah, and I also wanted to add that integrating with the Kubernetes native ingress stuff is like one of my primary 2 use cases. So if you're interested in working on that, please ping me offline. So I don't have bandwidth right now to push on the separation, but I would happily accept help.
Okay, got it. I don't know if I'll be able to contribute to that directly, but that's one of the use cases that I have where I have a similar Kubernetes cluster where I'm trying to launch the notebook servers along with the hub and the proxy itself, but you want to get rid of the configurable node proxy and plug in the ingress. So I noticed there is a sample project which actually tries to integrate Nginx with JupyterHub by providing the additional Lua functionality in Nginx.
Yes.
Is it going to be an extension of what you have, what you're going to do?
Yeah, so that is what is currently running the Data 8 infrastructure, actually. We've had better results running there, but it is not, like, it's kind of like a Franken monster because it pretends to be this Node.js thing where it is not. So that's like the reason we are abstracting this out is so that it can become a normal working sane piece of software rather than this Franken monster as it is now. But yeah, you can use that right now. It doesn't work for services because I didn't add that functionality in there. But it does work for users. And like even last semester, so it's been in use at Berkeley for about 9 months now, and it's fairly decent. So you're welcome to try using that as well. But the work we're doing is to enable that building like the Nginx proxy to be easier and also like to be just cleaner.
Okay, got it. Thank you.
Yeah, so right now, there isn't a spec for what JupyterHub needs. There's just what configurable HTTP proxy happens to do. And so we had to kind of look at what that does and ape it as a REST API and all this stuff rather than being able to just implement a simple spec, which is the goal, to make it easier to do that kind of thing.
Okay, got it.
Do we have any other questions from Dan? Any questions there?
I can't do Dan.
Communicate with us. That's all
Maybe
right.
Dan wants to talk about the fact that he's working on making the JupyterLab extension work better, so that you can use JupyterLab in as the single user server. So Dan's been working on that. All right. So that will be another thing that's kind of along the side that should be coming along.
And there's a repo under the JupyterHub org for that, right, Ben?
Yeah, Dan's working on the JupyterHub. I think it's just JupyterHub Lab extension.
Yeah.
I believe what it's called.
Yeah, I think that's it.
Great. Dan's been doing some great work with us, so it's been fun working with him. Good. I think he's blushing. All right. All right, guys. What else do we have? Other questions that we have out there?
So I've been trying to keep up with the hub share work and reading the spec and whatnot. I'm doing a poor job of it, but I was wondering, has there been any discussion yet of, discovering, like, if it's going to follow a full model, how do these shared artifacts, notebooks, whatever they are, get discovered? Is there any talk about searching them, those kinds of things, or is that just not discussed yet?
We haven't talked too much about that, but I think we're imagining a fairly smaller scale where basic search filtering, kind of on the order of like GitHub repo listing, is adequate. But if you want to chime in and add notions of tags and things toward, or if you have sharing goals that you'd like to see addressed by it, that would be appropriate. Because we have, there are instances like the CERN deployment. We're working on kind of scope limiting this thing because there are a million shared storage solution things, and one thing that I like a lot is that the CERN JupyterHub deployment uses basically I think an open source Dropbox type service, their version of which is called CERNbox, and that's what they mount in their JupyterHub instances. And that service has all this sharing semantics, so they already have this kind of fairly decent file sharing model, and it operates entirely outside JupyterHub's understanding, which is my favorite place for things to operate. And so I think we're aiming for the scope of HubShare to be fairly basic mechanisms of saying, I made a thing, I want to make it available to my fellow folks, and then making sure that things are discoverable and linkable and simple search.
I had a question about HubShare, which is, will there be, like, is HubShare going to be integrated into JupyterHub in the sense of, does JupyterHub know that HubShare is a thing that exists, or is that just one implementation that like will be easily swappable without having to, like, it's the same thing with the CHP, right? Like with CHP, I could replace it now if I mimic the API, but JupyterHub depends on that API. So will JupyterHub have intrinsic knowledge of the HubShare API or not?
The current plan is for JupyterHub to not know about HubShare at all. That HubShare is just another service, and then provides an extension to the single user server for basically the transfers in and out of HubShare. But that as far as the hub is concerned, HubShare is just a process that is a web server.
Cool.
And HubShare itself provides the extension for the single user server to talk to it.
Right. That's great. Thanks.
Min, I have a question from Dan, and he said, you mentioned that the notebook server itself monitors user activity, no longer relying solely on the proxy for this. Would this new feature of the server make it easier to write a service that culls idle kernels as opposed to servers?
Yes. If you look at the PR, that is it. The PR has exactly that in mind. So I had two things in mind. One was call idle kernels, and one is kind of a call idle servers. So there's a timestamp. There's a last activity timestamp on each kernel, and then there's a single last activity timestamp on the REST API as a whole. And so you can, and I can't remember. And then, so the last activity of the server, there's a single request you can make to get all of those, I believe. And then, so the last activity on the server is essentially the max of those timestamps. So yeah, you can absolutely. I even said in the initial PR that I would follow it up with another PR adding call idle kernels, but I never did that. But it should be very, very similar to the call idle server script for JupyterHub.
Thanks for the question, Dan. All right, anyone else?
Just to follow up on that, culling the idle servers, is it possible to integrate a plugin kind of an architecture where we define when and how these should be culled? Maybe based on some other event that happened outside of the JupyterHub environment completely.
Yeah, so JupyterHub has a REST API that if you have admin permissions, you can list users, get their most recent activity, start and stop them. So the call idle servers script is just part of the reason it exists is an example of using the JupyterHub REST API. So it partly exists as an example of what arbitrary external applications can do with JupyterHub. And what it does is just see what's idle and shut them down. So you could have your own external thing that identifies any other kind of resource usage kinds of things about user servers and shuts them down with whatever criteria. So the calling idle is not something in JupyterHub, it's entirely external. But JupyterHub provides enough information to make those decisions.
So if I understand this correctly, the configuration that are provided for cull idle time and then the periodicity or whatever the other variable was, that is just used by JupyterHub to call the script, which actually does the identification of the server needs to be culled or not.
Yeah, those arguments are passed directly to the script. So JupyterHub doesn't understand what the idle frequency or the period mean. That those are interpreted by the script. And the script just says, hey, JupyterHub, show me the latest timestamps. And then internal to the script, it says, which ones have been idle for a given period, and then makes requests to the JupyterHub API to shut them down. So you could look at the call idle server script, and then with an eye to modifying it to take additional criteria into account for your own services.
Okay, got it. Thanks.
Mm-hmm.
Yeah, and I dropped the link into the chat room to the example of the call idle that's in the JupyterHub main repo.
Thank you.
All right, great discussion. We still have about 10 minutes if anyone else has questions that they want to ask here.
Do we have a central list of or sorts of like various deployments that people have done in various places, and like we have like a way of reaching out to these people, so that we know how people are using it?
Not that I'm aware of.
It's on the list to do that Fernando and I talked about at back in San Diego before the year ended. But one of the things I was going to do is probably write a script to pull stuff from GitHub. So at least if people were using it in GitHub and were using the name JupyterHub, that we'd have some sense of what's being used out there.
We also have there's a Google Sheet started by Paco Nathan of Jupyter, uses of Jupyter in education. And I believe that also includes some JupyterHub deployments. So that's on the Jupyter in education mailing list. And I usually just search Google Sheets. So we're moving toward having a more comprehensive list, but that's what exists right now. And folks can add to that if you find that. I can try to find that and tack it into this repo so it's more accessible. Good question.
Thanks.
Sure.
Can you hear me?
Yep.
Hello. Okay. Just a question out of curiosity more than anything else. How large has someone effectively scaled a hub for teaching purposes? So hub plus Nbgrader.
Plus, so UV, the Data 8 doesn't use Nbgrader, right?
No, it does not.
So the largest Nbgrader deployment might be Jess's with about 250 students.
Yeah, and Data 8 is about 650 students, but without Nbgrader. And Wikimedia's hub, which is not used for teaching, has hit at least 1,000 something users, not all active at the same time. I think it's hit maybe an active 400 users at the same time, but we have more than 1,000 something users.
And resources-wise, what does it end up using?
For both Wikimedia's, so we basically guarantee, like on Data 8, 2 gigs of RAM per student. And so it's just basically like resources-wise, it's just 2 into like however many students we want. So we currently support about 400 concurrent students. So we need 800 gigs of RAM. So we have, I think, about 75 boxes or something with 15 gigs of RAM each. But it's like fairly flexible. So we like scale it down during the weekends, for example, because we know that most people aren't going to be using it. So yeah, that's where it is at. Same thing with Wikimedia as well. It runs on our common Kubernetes cluster, which runs lots of other things as well. So there is like no special use for this. Is that the kind of answer you're looking for, like in terms of resources?
Yeah, pretty much. I mean, the one thing that's holding me back from actually using JupyterHub as part of my course is scale. I would effectively have anywhere between 300 and 500 concurrent users.
Mm-hmm. Yeah,
it's like, generally
go on, man.
Memory is usually the limiting factor, is how much memory do your users need.
Mm-hmm.
Because if you're doing some data analysis thing, they need at least 2, 4, 8 gigs each, and then and that adds up pretty quickly. If they're doing really basic stuff, then you can get away with half a gig or even a quarter per user, and it works out okay. So it depends a lot on what the students are actually doing, because of course it's easy for them to accidentally request a bunch of memory.
Yeah, we're also keeping close track of how much RAM students are actually using over the semester, and I think that will help us determine that more accurately for the next semester. And also with the kubespawner, you can also make overcommit. So if you know that most of the times your students are going to use only 1 gig of RAM, and sometimes some of them might use more, you can overcommit appropriately. So you can allocate 20 gigs of RAM on a box with only 14 gigs, and then hope that people don't use that all at the same time. But of course, that's not something you want to do. But you can do that if you're short on resources. And we do that at Wikimedia because we're offering this for free, so we don't actually care. So.
Thanks.
Yeah, feel free to reach out to me if you want more info on that. And also, I know that Berkeley has their own grading stuff, and I can put you in touch with the people who run that as well.
Okay, thanks.
All right, folks. If there aren't any more questions, I'm muted. All right. If there are any more questions, we may go ahead and wrap up early. Sounds good to folks. I really want to thank Min and Jess and Carol and Brian and Yuvi and Min's cat for leading the discussion today. It's really great. I think, I also want to thank the core team for joining in today. So hopefully this helps inform your work. Yeah, that's it. Thanks again. I'm going to end the recording here and hope to see everybody soon.
Thanks.
Thank you, guys.